Hello and welcome to the second segment of the second module dealing more with scientific libraries in the Julia language. As always, we run some stuff to be sure to initialize the environment. We do not run instantiate as the environment is shared within the same module, so we already done it for the first segment of the second module, so we don't need to do it here. The first things we may want to do after we have some data is trying to visualize them, and that is to plot them. And so here is a section dealing with plotting functions and data. So in Julia there are many different plotting packages. Maybe it's a sign of still the language being young. We use the plots package that has the advantage to allow different backends. So plots give us a common API, a common interface to many different backends that we can choose at the runtime. So each backend will need a specific package, for example, pyplot for matplotlib, or plot lijs for plot li, that is a very famous plotting library in JavaScript. And the advantage is that we can plot something, and then maybe we don't like it, how the graphical output, or we want to change the backend. We just run one function, and that's all. We can try to plot using a different backgrounds, or maybe some plots we want to use one backend, and then other plots more specific are more come out more nice in another backend. So we can choose this backend by just running this function at the runtime. Also, we are not using exactly the plots package, but we're using another package called statsplots that works on top of the plots package by providing some convenient functionalities, for example, to work directly with data frames or to plot distribution functions and densities. And this functionality is done applying what are called recipes in the plots terminology, that are some low-level code that allow us to perform different type of plots, or different apply to different contexts, like I just said, to data frames or to distribution. So the idea here is that using statplots, we use these higher level functionalities. So for us, it doesn't change nothing, because statplots then export directly all the functionality of plots. So in general, don't use directly plots, but use statplots. So here we are using statplots, and there are different theoretical approach to plotting. What I like of plots is that it keep it very simple. The idea is that you print you plot one graphical element at a time, one series at a time. So the first one you call the plot function, and then you can add several, and we will see several series at the same times. But another approach is to plot one series, and then plot with the exclamation mark will plot on the same figure another series, maybe another completely kind of a chart. So you plot a histogram, or you plot a line or a scatter plot, and this is very easy to follow, because you first plot one, and then you modify As you know, the exclamation mark at the end of the name is a convention to say that this function modify, and indeed what it modify is modify the last plot. You can also give as first element here, as a first argument, another plot. So you can plot something and save this plot on a variable name, and then you can modify this variable name. But the most common approach is to just plot without saving, and without saving automatically Julia keep track of the last plot, the current plot, and then when you modify, it modify automatically the last plot. We are going to see it. So let's start by plotting functions, with the note that the first time that we do plot, it will take a while because the just-in-time compilation, this is a well-known problem in Julia. This referred to time to first plot. As you can see, it's gonna take some time. This happens only the first time that you run the plot function. You will see the next run will be very fast. So here you can see we are plotting our functions, and the range by default is between -5 to +5. So on Visual Studio Code you have the plot here. So you can see the range -5 to +5, and this is the cosine function. You can also plot any function. Here I'm defining an anonymous function of the squared, and I decided to put it -2 and 2 as ranges. So the function and the two extremes of the range. I can also do any other fancy design. Like here, I plot a maximum function between x and 2. I give it a label. I have the label here. I say that the line style has to be dots, the color needs to be black, I give a title to the chart. There is no subtitle, so I don't know why I put here. There is no way to put a subtitle here. I can add a label to the x-axis and as well to the y-axis, and then I say that I put the legend on the top left here. So a little bit the main things you want to do about plotting. And by the way, I forgot to say, here we are going to give really the basic of plotting, because plotting can become easily very complex. I'm not gonna plot here on some beautiful plots. You can see them if you go in the plots package. You have gallery of very beautiful plots, but they all really depending on your needs. Plotting can become something very time consuming depending on how much effort you want to put. Here we are just giving the basic of how the plots works, and then it's up to you to going to look for the documentation for plotting exactly the way you want. So that said, another very common way is to have multiple axes, and here you do that by twinning the x-axis, as giving this function twinx as first parameter. It will take the current figure and will twin it, and this is the way that we can plot on the second axis. Here you can see the number, the values are not on scale with the first axis, and here I give the RGB colors that I prefer, that I want. So that's for plotting functions. Often we want to plot data, so let's gonna create some fancy data, and with a data frame with A, B, and C column. I can plot, as I said, multiple series in one go. Here I just make a matrix of the data frames, and I plot the X, and each column of my data A, B, and C. Here is a different, interpreted as a different series. So the syntax is plot X as a column, must be a column vector, and then if you give a single column vector, you will print only one series. If you give it, as in this case, a matrix, each column will be a separate series. The alternative is to plot one at a time, and here I'm using it to show how to plot different kind of plots. So first here I'm plotting. I'm using, so this df markup come from the statsplot package. Is a recipe of statsplot package where I specify the data frame, and then I can refer to columns. Here I'm referring to a single column, but I could refer to multiple columns with just the name of the column as a symbol, so I don't need to specify data.a, data.b, and so on. You can see here that I specified here series type to be a bar, so I'm obtaining a bar plot, and I'm putting the legend here on the top left. Now I can so here I did plot one. Here I can modify my plot with the plot exclamation mark, where I put the B series, and as you can see here I'm using another type of series, that is the line, the default one, by the way, so I would not need to specify this one. And most of these series type, they have also an alias. So instead of specify plot series type type of the series, I can just use line, or I can use bar, or as in this case I can use scatter. So instead of putting scatter, would be the same to put plot and then series type equal to scatter, and this is actually what I prefer. Is I think is much more clean here, but if you for some reason prefer to plot directly with the alias, that's the way. And again, I'm using the Twinix tweak to plot on the second axis. So you can see here that I'm plotting here three different kind of plots and composing these in a single figure. Now, often you want to make complex layouts with different plots, and the simple ways is to use this layout macro, when you can use name places here ABC to specify how the layout should be composed. So here we have one row with only one plot, and then we have another row with two plots, and you can also specify things like which proportion or should be B and C, or if one should be fixed, and so on. Look for the documentation of the layout in plots for this, but this is the simple way. You just put the rows, and you put the name places, so how many plots you want to put in the different rows. So let's gonna put the first declare a first plot. As you can see here, I am saving the plot to a variable. So this P1 is referenced to one specific plot. The same for P2 and P3. And then I can call plot with my plots and specify the layout where they are to go, and I obtain my layout with this one P1, this one P2, and this P3. Attention that here I name it by coincidence the data frames with A, B, and C as here, but these two are not related, so I could have used any other names here. After you obtain your beautiful plots, you can save them, and this is the type, the main type format that you will want to use are most likely PNG, PDF, and vector form. So you don't need to specify, just give the correct file extension. So PNG will save as PNG, PDF will save as PDF, and SVG will save in vector form, in scalable vector graphic.